All right, Pre-Cal 11. I'd say this is everything you've been waiting for, but I know that my sarcasm will probably go through too dry. But this is it, okay? Quadratic equation. For those nasty quadratics that are tough to calculate, for those quadratics with a terms that you really don't want to do the AC method with, or even if you just want to see how it works every single time, you can use the quadratic equation. And this is the quadratic equation. Now, it is my philosophy that an equation like this, you should never have to memorize. Thing is you will use it enough that you will memorize it because it'll just get ingrained in your working memory. I'm going to show you at the end of this video how we got this equation, like where this came from. But I'm going to give you the equation. I just want you to make sure you know how to use it. So let's get right to it. A term, B term, C term. So when you got a tough quadratic, use the quadratic equation. Because if you were to try an AC method this, you'd be like, okay, x squared plus x minus 12. Are there two numbers that multiply to negative 12 and add to 4? Or sorry, multiply to negative 12 and add to positive 1. Yeah, there are. X minus, or plus 4, x minus 3. And then AC method says I would divide, and I would divide. And here I'm going to get x plus 2 and 2x minus 3. So x equals negative 2 and x equals 3 over 2. So you could do this one without the quadratic equation, but watch this. So my b term, it's a 1. So negative b, so if it's plus 1, I'm going to have negative 1 plus or minus the square root of, and we'll get to this later, but what's underneath here is called the discriminant. Okay, everything underneath the square root sign, and we'll get to that near the end of this. But negative 1, so b squared, so 1 squared minus 4 times a times c all over 2 times a. And then you just work this out. So now negative 1 plus or minus the square root of 1 minus negative 48 over 4, which is negative 1 plus or minus root 49 over 4. So that's where we get negative 1 plus or minus 7 over 4. So you're going to get negative 1 plus 7, so 6 over 4, which is the 3 over 2. And negative 1 minus 7, negative 8 over 4, which is negative 2. So that's where that comes from, and that's where that comes from. Quadratic equation does it as well. Now, sometimes you won't be able to not use a quadratic equation. Like if we look at this next one, if I tried the AC method here, now I'm looking for two numbers that multiply to 12 and add to 2, and that's just not going to happen, right? Like 12 and 1, 6 and 2, 3 and 4, no. So this is a quadratic equation question. A, B, B, C. So negative B, so negative 2, plus or minus the square root of B squared minus 4 times A times C all over 2 times A. Negative 2, and when you get good at this, you don't need to show as many steps, but I'm going to show you. So negative 2 plus or minus 4 minus negative 48 all over 6. So I think I might have made a multiplication here. No, that looks good. So now negative 2 plus or minus root 52 all over 6. And here's where we get to simplifying radicals, right? So what's root 52? Well, root 52 is negative 2 plus or minus root 4 times 13. Now we do that because I like to be able to factor out if I can. So simplify out of my radical, root 4 becomes 2, and then what's left is the root 13. This is radical simplification from grade 10. You should be comfortable with it. You should be happy with it because we do expect things to be simplified. And now since you have a 2 as a factor and now you have a factor here, you can cancel the 2 out of there. And you're left with negative 1 plus or minus root 13 over 3. So your two solutions, this gives you your solutions, right? X equals -1 plus root 13 over 3, and x equals -1 minus root 13 over 3. You'll find that these are long, never-ending decimals, but they do exist on this graph, right? They're a real number. The hard thing to grasp is that if it's a never-ending decimal, how does it exist, right? An irrational number, non-repeating, non-terminating, but it's there. It exists in this real space. So let's do a couple more. Now, first, this isn't going to work, right? We need to be equal to 0. So 2x squared minus 3x plus 4 is 0. And now you got your ABC. So negative b, but careful here, it's -3. So negative b is +3, plus or minus b squared minus 4 times a times c all over 2 times a. Now we're going to get 3 plus or minus the square root of 9 minus 32 over 4. I don't know about you, but alarm bells are going off in my head because 9 minus 32 is -23. This is not allowed. So you're done. No solution. Those are always nice. And that's where we're going to talk about the discriminant, right? So let's look at the next question down. Example 4. So off the top of your head, can you tell me what the quadratic equation is right now? I wonder if you can. Do you need to see it, or have you used it enough times now that you know what it is? What do you think? I'm just messing with you, okay? It's -b plus or minus the square root of b squared minus 4ac all over 2a. I once joked with my wife that I would get it tattooed on my arm, and she basically just laughed me out of the house. So again, we have a negative number here. So b is positive. Negative b is positive. Plus or minus. I'm going to do this right away. 12 squared is 144. Minus 4 times a times c all over 2 times a. So now 12 plus or minus root 144, 16 times 9, 144. So this is a scenario where this could have been factorable using AC method, because look what we get, right? We get a discriminant of 0. So we get 12 plus or minus root 0 over 18. So what you're just left with is 12 over 18, which is 2 over 3. So we only have one solution. So we're sitting right on the x-axis. Perfect. Okay, so that's quadratic equation, right? There isn't much I can teach you about it because we're using it. But let's just look here at the discriminant. So this is that part inside the radical, right? The b squared minus 4ac. If this is a greater than 0, which means if it's a positive number, you're going to have two solutions. If it's equal to 0, you're going to have what we just saw, one solution. And if it's negative, you're done, 0 solutions. So that's how the discriminant, if you look at just the discriminant of the quadratic equation, it can tell you how many solutions you're going to have. So it can be pretty handy. So now what I'm going to do, I'm going to do my best to kind of off the cuff this here. And I'm going to show you, I got enough space. I'm going to show you how the quadratic equation came into existence, how they derived it. And what you need to consider is so first let's write it up here. Negative b plus or minus b squared, the square root of b squared minus 4 times a times c all over 2a. Okay, you need to consider this, ax squared plus bx plus c equals 0, standard form of the equation. Let's complete the square of this thing, because what we have, right, is we have x equals. So let's take this and let's complete the square. Find the vertex, right? Convert this into vertex formula. So I'm going to boot the c out, and for the sake of this, I'm actually going to put the c on the other side of the equation. I'm going to subtract c from both sides. Now what I'm going to do is I'm going to divide my b by 2. Well, sorry. First I have to factor out the a, right? And you end up here. And I'm going to divide this term by 2 and then square it. So you end up with this. So plus b over 2a, so that's it divided by 2, right? Squared, minus b over 2a, not to the power of 4, squared, equals negative c. Now, when this comes out, it needs to multiply with this. But it's important to remember that before it comes out, let's write it in what it actually looks like. Because it's squared, right? So you're going to have b over ax plus b squared over 4a squared. So I've just brought that into both of those. I'm going to do that here as well. Minus b squared over 4a squared. Because now when that thing comes out of the brackets, it multiplies by a, and the a cancels with the a squared. So you're going to have a x squared plus b over ax plus, I'm going to put this back to what we'd like it to look like, b over 2a squared. And then when this comes out, right, we'll close these brackets, we have negative b squared over 4a, not a squared because it canceled with the other a, and that equals negative c. So now I'm going to put this into vertex form. So a, and it's x plus b over 2a all squared, right? Just thinking here for a second. Yeah, that should be fine. I'm just going to, for my brain, I'm going to go x plus b over 2a times, because I want to make sure I'm doing this right. And if not, then this whole end of the video is a waste of time. But that's going to give me plus 2b over 2a. So those cancel. Okay, good. And then, yep, okay, so that's perfect. So this is good. And then we'll go equals. I'll go back to red. Sorry. Equals, and I'm going to add this to both sides. So b squared over 4a minus c. So you see now we're actually getting kind of close to getting an x by itself, because that's the overall goal. So now I'm going to divide both sides by a to get rid of this a, right? Boom, divide, so I want that a out. Oh, that actually just deleted my last step, so let me rewrite that. A x plus b over 2a all squared equals b squared over 4a minus c. I'm going to divide both sides by a, and you get x plus b over 2a all squared equals b squared over 4a squared, because I'm multiplying by 1 over a, or dividing by a, minus c over a. So, on the right here, this side, let's get a common denominator. So we have x plus b over 2a all squared equals b squared minus 4ac, are you starting to see something here? Over 4a squared. We've seen that b squared minus 4ac before. Now we're going to square root both sides. So you have x plus b over 2a equals the square root of b squared minus 4ac all over 4a squared. Now, if you square root the top, you can't do anything. but the whole bottom can square root. And you end up with 2a. And now if you subtract b over 2a from both sides, and sorry, when we square root plus or minus, we have negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And would you look at that? If I just bump this plus or minus up, I have a common denominator. Rated over the same denominator. There's your quadratic equation. So that's how it was derived originally, using the square root method. I mean, that's a lot of steps. I don't need you to memorize that or anything, but like that's crazy. Using the standard form equation, completing the square to find a vertex, right? And then solving for x, and you get the quadratic equation. Beautiful stuff. I hope you guys enjoyed that little bonus video. Take care.